Hello, everyone. I'm going to be talking about GraphQL. Well, thanks everyone for being here, by the way. I didn't expect as many people. So first of all, this is like my who am I slide. I'm Jelmer. I work at Manifolds. There's like a bunch of Manifold people here. I led the initial version of the GraphQL API there, so that's like one of the reasons I need to speak up. Okay, one of the reasons I'm speaking about GraphQL now, but I actually mostly do Go and like backend things and like ops things as well. Apparently sometimes, and I actually really like performance and like reliability and scalability issues, and just like a passion of mine. You can find me on GitHub like that and Twitter as well. So GraphQL. Before we start, actually, I'm just going to zoom in this a little bit so I can read my notes. Before we start, has anyone used GraphQL? And I know obviously a few people, but okay. Has anyone implemented, like of those people raising their hands, has anyone implemented a GraphQL server before? Okay. And who's running that server in production? All right.
Doing it count?
Sorry?
Was you running in production for its count?
I actually don't run it. I just set it up and then other people run it now. Good question. Okay, so yeah, it's like a lot of hands and then lower and lower. So yeah, I'll go into like what GraphQL is a little bit. I don't have an overview slide, but basically what we'll cover is like what GraphQL is, some like reasons why to actually use GraphQL and like potentially not use GraphQL, and then like some like general like struggle points that you can come up with or like get against. A quick history lesson. So it's created by Facebook, like React as well. It's created by Facebook in 2012. It's actually open source in 2015, and then in 2018, I think November it was, they moved it from like Facebook to like the GraphQL Foundation, and the GraphQL Foundation is like part of the Linux Foundation. People who are familiar with that. I'm going to give you a wall of text now, and this is like the definition of GraphQL from the GraphQL.org website. So I don't know how clear it is, but like I put some things in bold, and that's the stuff that we'll dive into. So GraphQL is a query language for APIs and the runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API, gives clients the power to ask for exactly what they need and nothing more. And then lastly, makes it easier to evolve APIs over time and enables powerful development tools. I didn't put the last one in bold because I'm actually going to use that part quite a bit for like demonstration. And demonstration is actually going to happen with everyone, well, probably not everyone's favorite movie, but I'm bold claim here, it's Star Wars. So the GraphQL documentation is actually using Star Wars quite a bit. And like in the documentation, you'll see actually like a Star Wars API. And as you can see at the top here, this is literally like actually the GraphQL documentation stuff, and they actually do have the Star Wars API in GraphQL, so we use that throughout the examples here. And that's like how you can play with it as well. There's a few things lacking, so I actually have another API open as well that we can dive into with that. So the first thing that we mentioned, or like not the first thing in the whole list, but one of the first things that like is quite interesting is that it's descriptive. So like what that actually means is just it's a typed system, and you can like have a like type system like schema basically to define your API. That looks like this. So you can have your models. You can find those as like proper like structures where you can say like, oh, this is a new struct or a type rather. So I come from Go and I think in structs. But you have a type which is like everything is typed as well. So you have like a name which is string, and then you have starships which is an array of starships, and then in that starship you have like multiple like other fields basically. There's like a bunch of scholar types, and then you can like obviously define your own. Like you see lists here, and then you can also have functions. We'll dive into that in a little bit, and that's actually the like really interesting part, if you ask me. And like especially like for things like pagination and stuff, that will come clearer later on. There's like enum types as well. Like you see the length unit, that's an enum type, so that's supported as well. And then you also have like queries. So you have a regular like fetch query, which is like first example here. Like you can get a person, you can get a set of films. So the second one, the films, is already an example of like what pagination looks like. And again, we'll dive into that a little bit. And then the second example is actually how to like update or create things. So in this example, for some reason, my update example is blank. But like create person, like with some input, and then you get some output. And there's also another type that you can have, which is subscriptions, but I'm not going to dive into that now. But that's actually quite a cool feature, like that you can look into afterwards. So yeah, one of the biggest things of like GraphQL is like it's in the name, it's QL, query language. But what does that actually mean? So if you think about like the name again, like it says graph, and this is actually the GraphQL logo. So that means like we're gonna think in terms of graphs. Like everything is connected. So these are like nodes in a graph, and like if you think about like that top node, like how can you figure out the relationship with that bottom node that's going to like either like the full circle, or like you can like cut in between it. It's like figuring out that connection. That's what GraphQL enables you to do, is like building that like that connection with that query language, which we'll dive into in a bit. We're going to look into that with an example, again, with Star Wars API. And this is like an abstract thing that I found on the internet. But it's basically the relationship between all the characters of all the movies. Like, so the link between like the characters, like how they like relate in the movies themselves. And it like you can see here, there's like a bunch of nodes. So like, how can we represent that in a query? And this is how we do that in GraphQL. So like, this is like the powerful part is like, you can make that very descriptive. You can say like, oh, I'm going to fetch this person by ID. For some reason, the Star Wars API doesn't have like find it by name, which is a bit sad. But so this is actually Luke Skywalker. So you can get the name out. Then you can like list all the films. For those films, you can say, get me the title as well. And then again, for each film, you can get the characters. And then you can list the name of that as well. So now you basically had that social graph written in code, or like a DSL rather, to like say, oh, get me that information pretty easily. Thinking about that again in graphs, that actually looks like this. So in the middle, you have that person. Then that branches out to the films, and then that branches out to each character again. I'm going to quickly run this. Oh, I didn't prepare it, but let me. Oh, great. This is the issue with ID. Let me actually. Yes. So this is not the query I wanted to show. I just had to copy paste the ID because I obviously don't want to type that. So let me say name. So we'll get the first. No, let's say 10. A bit less, obviously, but we'll dive into what these edges and node things mean in a bit with pagination. Just assume it's a list for now. And then you can say bye. So we'll run this for the first draft. So again, this is Luke Skywalker, and then we get all the films. So let me remove this for a second. Is that clear for everyone? Cool. But then, as I mentioned, you can even dive even deeper. So then for each film, you get like all the characters there as well. Well, all depending on how much you say for that you want, and that way, like you actually build that full graph and like can figure out like how everyone is connected to each other. So yeah. Oh, I didn't realize I had a screenshot of that, but there we go. I guess it's not clear anyway because it's pretty small. So second part of that whole description was they emphasized on the runtime. So you can imagine like you have this DSL now, like, but how are you actually going to convert that DSL into something that you can use to actually query your data? So that's what was in the documentation, a runtime for fulfilling those queries. So we wrote that query, but how are we going to actually get that data now? Like how are we going to go from that query to actually like getting that JSON out? That's like a thing where GraphQL actually like provides you a little bit of help. Like there's getting ahead of myself. There's a lot of server implementation in a lot of languages. I think I'll have examples of Apollo, which is like a JavaScript one. But at Manifold we use like a Go one, which is called GQL Gen, I think. There's like for every language basically you have one. And they basically implement this runtime for you that like helps you like enabling this stuff. How you get all this data is actually through resolvers. And what you can think about resolvers is basically everything is a function. Like every field on your struct or on your types rather is a function. So that name, that's a function. That connection, that film connection, that's a function. And that's what resolvers are. So we'll have a quick look at this. So this is a root query. So as you can see, oh, not this one. Let's do this. So this is root query. This is like the first query that you execute. And then we actually like have queries down there as well. Like this is the second query. And this is actually second query as well, the name. But this is a root query. And we get 4 arguments or like 4 params basically in that function. The object. So the root one is a special case. In this case, it will be null. But everything else, if you go down the graph, that object will be the previously used like loaded object that you have. So you have a reference to the previous item or that you loaded. Then you have arguments, which are the arguments in your query. Like I had ID, but you can put there like put whatever you want. Context, which is like dependency injection, and then info, which just gives you more information about the actual like query itself. Like you can figure out what the handler name is. The arguments should be the complexity, which we'll dive into a bit later on, stuff like that. But as you can see, this is a function. What we're going to do here is going to load this person by ID from the argument, and then we're going to get that person data. We're going to make a new object, person. Then the person type is like has another function, name again. So again, like everything is a function, but this one is actually pretty simple. We have that reference to the object, but because we loaded that object from the database, we actually already have that name, so we don't really have to do anything special. So we just say, oh, return that value immediately. So this is like nothing complex, like for that function, but we can like go a little bit like more complex if we think about those starships, right? So those starships, like we actually want to return like actual information about those starships, but that's like not related to that model or like that person itself. So we actually have to go and load that from the database. But we only want to do that if the user says, I want this data, which is basically lazy loading. And we'll get into this specific part of GraphQL a bit as well. So in this case, we'll say, oh, get me all the IDs, and load all of that information from the database again, and put each one of them, put that in the new Starship model, or like new type, and put that in a map. So yeah, that's resolvers basically. So like it's important to like that from like with GraphQL, like everything is basically like that. Every field that you have is a resolver, and it can be a simple one, which is like the name one, where you just return the value of that field, or it can be like a more complex one. Like at manifolds, we like have resolvers that are like pretty complex, where we actually like mash multiple things of data together, and like that's like quite interesting that you like when you think about that in terms of function. So we've seen what GraphQL is now. Actually, have a sip. But why should you use it, or why should you not use it? I think that's like a question that a lot of people want answers to, especially if they start looking at GraphQL. Why should we not use it? First one I'm going to retouch is that whole query language and like the runtime. Because like personally, I find it quite powerful. Because I don't think I have a slide for it actually. No. But we saw like we can think about everything in graphs now. We saw the logo, like that's a graph. We then saw that person to like films to like character connection. Everything is graph. And previously, you had to like have your data in a graph database to actually like start querying your data as a graph. But with GraphQL, you can actually just use any data storage that you want, and turn that into something that you can query as a graph. Like the actual like Star Wars API, GraphQL example, is actually using a different REST API under the hood, like as its database. But you can use like a NoSQL thing, like you can use like we're using internally, we're using gRPC endpoints for that. Like you can basically put whatever you want under that, which is quite powerful. And then that combined with the runtime. So this example, I actually cheated a little bit on this. This is actually not the actual screenshot of it. This is a manifold example that's like stripped down, but I didn't have access to the information from the Star Wars one. But if you execute a query in GraphQL, that runtime takes care of a lot of things. So if you look back at this query, so we say, oh, load this person, load the name, and then load the film connection and load the character connection. You can actually like kind of see that in here. So what we're going to do is we're going to load that person. Then we're going to say, oh, we're going to load all the films, and then for every film we're going to load just all the people, and that happens in parallel. And the interesting part here is that we actually like we didn't have to like think about like doing that in parallel. Like we didn't have to like if you have a REST API, we didn't have to load this and then fire off different requests to like get all this film information. GraphQL takes care of that for you. Like your runtime does that, and like every language like implements that in its own way. But that's a powerful concept that GraphQL has to like do all of these things in parallel. It has some downsides, which we'll get into in a bit. But yeah, that's to me that's one of the powerful things. As for what you need, so I showed you earlier that you can like get data, and the results are like, oh, yeah, you get all this data that you're asking for, right? And that's like a very powerful concept, like in general. If you think about like, if you just want a name, if you have a REST API that describes a full person, you would get like a massive amount of JSON back. But here we just get like this tiny bit of JSON back. And then if I want more information, you'll get more information. So you get the data that you're asking for, nothing more, nothing less. Sometimes less if there's no data available. But that's actually a very powerful part of it for like fallbacks and stuff like that. But well, you can actually do that in REST as well if you're starting to use field masks. this is not very common in REST, but like there's this thing that you can actually use masks where you can say like, I just want to use this thing. I know that we have it in gRPC as well, but like this is like it's getting very interesting if you start using like advanced connections. Again, like this, so a connection is basically something that is not standard to that object that you need a relationship for, and you're loading extra data. So you're actually combining multiple requests in one request here, and basically saying like, oh, I want this specific data. So if you wouldn't say Starship connection, you don't get that information, and that's not happening. But if you do specify that, you do get that information. So like that is a very powerful concept for this as well. Cool. Versioning deprecation. I'll just show you. It's yeah, like in my notes I have ever made an API change, like an API that didn't have to change ever. Like every API has to change, right? Like, and GraphQL actually makes that quite easy. Additions are like in every API, like REST API, are quite easy to do. You just add fields, and then if people use it, they use it. But the tricky part is when you want to start removing fields. Like if you want to remove a field from your REST API, you kind of like either like deprecate it and like never remove it, or you've got a new version of your API. In GraphQL, there's an annotation that you can use, deprecate it, and then people will actually like get like in their clients, they will like be able to see like, oh, this field, like you shouldn't probably use that anymore. And that way, yeah, you can start like gradually like phasing something out, and eventually you can remove that whole field. Error handling. So this is a little bit back what I mentioned. Sometimes a field can be like not there. This is also like a tricky bit in GraphQL. So with GraphQL, everything is actually 200. If your request fails, you're getting a 200 back. Unless your GraphQL server is actually blowing up, you probably get a 500. But if it's an error, like if something is not found, like a 404, like generally, you'll get a 200 back. If you're not authenticated, you'll get 200 back. So like, how are you doing that? So here's an example. Like I can quickly show you. Let me do this. So we get all this information now with this query, but so I changed this first from 10 to -10, and it's saying like, oh, that can't, like, you can't have the -10 because there's another verb that it says before, which basically covers that. And I'm getting a bunch of errors back, right? Saying I can't do this, but then I also get a bunch of actual data back, which is pretty cool because that way I can actually, and you can see, oh, the character connection is null now. But that way, like, I can actually start falling back. Like, I can give my users a better user experience because, well, I can still show them data. I can still show them all the films. Can't show them the characters, but I can still show them some data. And that's a very powerful concept, basically. So yeah, that's error handling. Performance. Performance is often quoted as like an issue with GraphQL. Like, there's multiple parts of that. The first one is a lot of implementations just do post requests. So you have like you use a client, and that's doing post requests. Like, to get the same data to do your regular query, you're doing a post request, but you can't cache that. Technically you can, but you shouldn't cache post requests. So the tip there is like actually start using GET requests. Like, there's like probably like browser limits that you have to think about, and like with that in mind, you have to like cut down on like some queries will probably still be going post request, but you kind of want to be able to like say, oh, I'm going to cache this data, especially like at the CDN level. If you're fetching, like again, if you're fetching this data constantly, you don't want to have to like hit your server constantly for that. You just want to cache that. And so this is a GraphQL, which is like a standard tool, by the way, that comes with GraphQL. But you can see they actually do GET requests. which is pretty good because that can actually be cached. But yeah, a lot of implementations just use Postgres. So if you are going to start using GraphQL, look into actually making sure that you can configure some things to be get as well. Another one is another example. Your queries can become quite complex because like you can actually start building more and more and like keep going. Like in this one, I can say film connection. You see where I'm going with this? And then I can say character connection again, and like you can keep going, right? So these queries can become quite complex. So you want to like start thinking about that. There's two parts of that. So there's complexity limits. So GraphQL actually allows you to calculate how complex a query is. So say that name is like, that's not complex at all, right? Because when we load that object, we know what the name is. But loading the films for a specific character is like a little bit more complex. So you're going to give that a score of 1, for example. And then you can start building on top of that. Like you can say like, oh, I have something that is very resource intensive to calculate, like a price something that's like, yeah, hard to calculate. I'm going to give that a score of 5. You can actually start saying like, oh, every request should be within 50 complexity limits. Or you can do API rate limiting instead of doing requests. You can say, oh, I'm going to do API rate limiting based on complexity. Because like they can ask like a very simple query over and over again, but that doesn't really matter for your system. But if they're going to ask like queries that are very complex to calculate, you kind of want to like limit that. So think about that. And also start using data loaders. That's like a concept, and that's very well documented in the GraphQL documentation as well, but which basically smashes a bunch of requests together that are similar. So instead of for every film getting all the characters every single time, it's going to say, oh, I'm going to make a data loader. So you actually have to add some extra code to that. You're going to make a data loader, which then says, I'm going to figure out, like combine all of that request into a single request and get all the characters for all these movies in one request and then just match it up again at the end. So that's like a performance thing that you can do with that. But yeah, performance with GraphQL can sometimes be a bottleneck. So be aware of that. Oh, there we go. Yeah. Then best practices. I actually don't know. I think I'm almost out of time, aren't I? Pagination. Yeah. So it's widely like recommended to use cursor-based pagination. That allows you to like do forward pagination, backward pagination really easily, and it allows you to like get like get a good understanding of where you are in like the tree as well. That works with edges and some page info. And we'll also like for pagination, it's also like good to like use global object identification, which we'll get into in a bit. Just gonna give, okay, so this is the query I showed earlier. I'll run this in a bit live. But yeah, so this part between brackets here, the first like is like a verb that is very commonly used for pagination, just saying like I want the first X amount in this case, then after this specific cursor. So that weird string is basically cursor, and that's saying like this is where you are in the data set, and I want the first then after that specific cursor. It's actually including that one as well. You also have the last instead of first, so you can actually say give me the last after this set. And you can also query before. So this is all stuff you actually have to implement yourself. This is not like magic by GraphQL, but it's like commonly used in GraphQL APIs. Instead of showing that, I'll just, yeah, just run it. It might be easier. So yeah, you can say the first 10. name. And then we'll see first then. But if we change that to the last then, we'll get different names. So this is like the last piece of the set. And then you can say, give me the cursor. Oh. So this is that identification object that you can then use in saying like, oh, get me the information after or before that. So I'm saying the last 10 here. Let's see if I get the last 10 actually before that. Oh, I should probably learn to type. So yeah, that's different results again, stuff like that. And then another part of pagination is the page info that we have here. So that has like a start cursor, end cursor, has, next, and has previous. And that will just like allow you, like that will give you some information of like, oh, actually I need to keep paginating forward or backwards. Like if you're going the first or the last 10, you're going to want to see like, oh, is there actually a page before that or not? And you can use that like extra metadata basically to use some pagination queries, because like you want to loop over that information. Right? One piece of advice is paginate everything, because if you don't start adding it, it will be hard. The second part for pagination, or like it's not necessarily pagination, but it actually comes in handy with pagination, especially if you start doing nested pagination, is global object identification. It allows you to refetch data without actually having to know what the type is, like without actually having to know what the query is. Allows for caching as well, so you don't have to like write all the queries, and then like, because it's a simpler query, it allows for caching more like better in a better way, because like the query is always going to be the same for whatever data it is. And you do that by a simple node query. So I actually have this example here. I'll use a screenshot because the IDs again. So in this case, we use ID, this one, which is Luke Skywalker again. But if we change this ID, we're actually getting a film instead. So we can say, oh, load this node, and by this ID in the backend, we're going to know like, oh, this is this type of ID, so I need to load this type of user. But this single query can like resolve multiple types of data. And by using this syntax, you can say like, oh, if it's a person type, load this information. If it's a film type, load this information. Then the last one is input and output objects for mutations. And for that one, I'm actually going to go to the GitHub API. So again, this is like that whole GraphQL thing, and that actually has a bunch of like, it has documentation built in, which is to me quite useful, because that way like you don't have to like figure out with like playing around with curl and stuff like that. You can literally just read it and like copy paste things. But let's create. So yeah, you have create issue, like we're going to create an issue here. So you have create issue here, and you want to give that an input object. So you want to give it an input object, so you don't have to have like a billion like params in your function call. Oh, zoom in, yes. Sorry. Is that better? So yeah, you want to have like an input object basically, which has like all the information that you want to input. And then you can just use that as an argument as well in your function call, or your query rather. So the important part here is that instead of query, you actually need to use mutation now to like say we're going to do mutation instead of query. And then the important part is that you actually also return that object that you created or updated immediately. So you can actually start using that immediately as well. So I'm going to close this. I'm going to say, I don't know, do this. And then that's mutation. Like you can immediately, like you get immediately that information back. So if I would have more information here. I actually don't know what's more in it, but project cards, I don't know. That is. Oh, that's an edge. Let's try something else. Author, there we go. State. Login. So I can immediately get all that information back, even though I didn't specify any of this information. I get that back immediately from the API, and that's if you put in like if your return value is that object immediately. So yeah, that's recommended to use that. And here at the bottom, I have an example of how you define that. But yeah, so this is like the implements node thing. That's for the query step earlier. So input type is another special case with GraphQL. You want to use that for mutations. And then, as you can see here, make sure that you return an object. That's it. Well, thanks for listening.